Right, okay, and the first thing is revision. Okay, so there was 2 chapters in the Junior Cert book on area and volume. Right, I'll probably just do the whole 2 chapters in about 5 minutes, okay? Right, so you have to bear with me. So first thing is a square. So we're on, right, some facts about a square. Right, okay? So, facts about a square, right? All sides are equal. All sides are equal. Please say you all know that. You all know that. Right? All angles are equal and are 90 degrees. All angles are 90 degrees. Right? Perimeter is, so if I say one side is x, perimeter is 4 multiplied by x. X plus x plus x plus x plus x. Perimeter is 4x. Area is x squared. Because x squared, right? Diagonals, using Pythagoras' theorem, you know, the square and the hypotenuse is equal to the sum of the squares on the other 2 sides. The diagonal works out to be root 2x. Now, you don't need to remember that because you can actually use Pythagoras' theorem. Right? Remember, right angle triangle, if you go, right, okay, right angle triangle there, see that? Square and the hypotenuse is equal to the sum of the squares of the other 2 sides. This is the hypotenuse. So h squared equals x squared plus x squared. So that means h squared equals 2x squared. So that means h is equal to root 2x. Right, that's where that came from. Don't worry about it, just know you need to apply Pythagoras' theorem. Right, do you remember Pythagoras' theorem? I'll take that as a yes, of course we do. Right, diagonals are perpendicular. This is important. Right? Right, the diagonals are perpendicular to each other. So in a square, there's 4 right angles there in the middle. So in the middle there's 4 right angles. So that's what diagonals perpendicular means. Right, okay, and they bisect each other. So that means they cut each other in half. So that means the length of that line is equal to the length of that line, is equal to the length of that line, is equal to the length of that line. Okay? Right, so they bisect each other, they cut each other in half, and because they're all equal to start with, you have 4 equal lines in there. Okay? Which makes 4 isosceles triangles, right? Okay? Which you might have to use. Okay? Is that right? Squares? Any questions on that? Right, okay. Rectangle, can I move? No? Right, the next thing is a bit on rectangles. Right, okay. I might actually cheat a bit here, because we're basically right, can I rub this out? I will. Right, so we all know a rectangle. Oh, for God's sake, try and draw a straight line. Right, okay. So I'm going to change all sides are equal to opposite sides are equal. opposite sides are equal, all angles are 90 degrees, the perimeter is, if the length is y and the width is x, the perimeter is 2 times x plus y. The area is length by width, x multiplied by y. Right, okay. Using Pythagoras' theorem, the diagonal is equal to the square root of x squared plus y squared. Again, you don't need to remember that, you just need to know that you're able to apply Pythagoras' theorem, right? So, as in the diagonal there, d squared equals x squared plus y squared, so that means d is equal to the square root of x squared plus y squared. Okay, right, yeah, sorry, oh, there's a box stopping it. Yeah, you're okay. Right, diagonals, they're not perpendicular anymore, but they do bisect each other, right? Okay, so they don't make right angles at the center anymore. Okay, but they do bisect each other, so that means the length of that line is equal to the length of that line, and the length of that line is equal to the length of that line. Okay, is that right? So that's rectangles. I never wrote rectangle there. Okay, we good? Can I go? No. Sorry. Parallelograms are next. Can I go? Right, so a parallelogram, right, started off as a rectangle and someone came along and pushed it over to the side. So opposite sides are equal. Yep. Equal and parallel, obviously, right? It's a parallelogram, that's where it gets its name. Right, the angles aren't 90 anymore, but opposite angles are equal. And also, girls, the adjacent angles, so that angle and that angle, right? Okay, so will I just call this angle A, and angle B, and angle C, and angle D? So if you take any two adjacent angles, they add to 180. So A plus B will give me 180. Okay, so A plus B. If you take, I'm not writing out all the combinations, but if you take any two adjacent angles, D plus what will give me 180? D plus what? D plus adjacent angle, the angle next to it, D plus C is 180. Or I could have said, what could I have said? D plus A will give me 180. Is that okay? So, do you get what I'm saying? I'm only missing C plus B equals 180. So, does that make sense to everyone? Right, kind of adjacent angles, the angles beside each other, they add to 180. So if you have one angle in a parallelogram, you have them all. Agreed? Right, okay. Perimeter is the same as for a rectangle. Equals, so if I call this x, this is y, it's 2 times x plus y. Right, the area of a parallelogram is given by the base multiplied by the perpendicular height. So BH, right? You know the way a triangle is half the base by the perpendicular height? Well, a parallelogram is 2 triangles, so you don't have it anymore, right? So the base being, can be y, so it would be half of y by h in this case. H is a perpendicular distance, right? So perpendicular distance, so from the bottom line straight up to the top. Remember, it can be anywhere. So it can be in here, right? Okay, it can be here. It could be on the outside. They could put it out here. Is that okay? So perpendicular distance h. We all okay? Now, for the perpendicular distance, girls, right? Okay, I'm just going to take this one here. See this one here? Right. So I'm going to call that, see that? What have I made there for the perpendicular distance? I've made a right angle triangle, haven't I? Right, okay. So I'm going to call this C. This is where SOHCAHTOA comes into it. Right, okay. So so if this was this is x, because it's the side of the parallelogram. Is that okay? That's x. This is the height, and I'm going to call that angle C, because that's what I have it up there. See, that's x as well. That's what I called it originally. Okay, are we all okay with that? Right, and I can say sine of C is the opposite, which is h over the hypotenuse. Right? Agreed? Remember SOHCAHTOA from Junior Cert? The sine of an angle is SOHCAHTOA. Did you learn SOHCAHTOA? Or did you learn oh hell another hour of algebra? Or did you learn silly old herring or silly old hen or something? I don't know, I can't remember. Yeah, SOHCAHTOA is what I go with anyway. So you know, this is the opposite, this is the adjacent, and this is the hypotenuse. Do you remember, yeah, I don't know, is it blank faces or board faces? Blank faces? Board faces. We're okay? Board? Right, that's fine. I can cope with board. Blank I have to fix. Yeah? We're okay? So, opposite over hypotenuse. So look, if I cross multiply there, h is equal to x sine c. Isn't that right? So you know the way over here I had, why did I put a half in there? Shouldn't be a half. Yx. So instead of h, I could call, so that would be y. Instead of h, I can say that's x sine c. Right, okay, so what basically you're saying is, to get the area of a parallelogram, it's the length multiplied by the width, multiplied by the sine of the included angle. The sine of the angle in the middle. Okay? Again, don't worry about that if it doesn't make sense just yet. Okay? And the last thing I need to write down about parallelograms is the diagonals still bisect each other. So the diagonals still bisect each other. So I'll just put that there at the end. Is that alright? As I say, lots of information coming at you. Right? Okay? But there's nothing new. You're supposed to, except for the yx sine c, but everything else is kind of just a revision of what you learnt in primary school, junior cert, etc. Right? Okay? And the last thing I need to talk about is triangles. Right? Okay, for the moment. Actually, there's a lot more shapes I need to talk about, but Right, next one is triangles. Right, okay. So I'll just take kind of a X, Y, Z. You all remember what an isosceles, a scalene triangle is? Isosceles triangle, equilateral triangle, don't you? Scalene, no equal sides, no equal angles. Isosceles, 2 equal sides, 2 equal angles. Equilateral, 3 equal sides, 3 equal angles, and they're all 60 because they're all equal. Right, you remember that, do you? Right, okay. Right, perimeter. There is no formula for a perimeter. You just have to add up the length of the 3 sides. So it's X plus Y plus Z. Right, area equals half the base by the perpendicular height. So it's a half the base by the perpendicular height. So again, in this triangle, that would be a half multiplied by Z multiplied by the perpendicular height, which is h. What am I going to do now? Yeah, I'll just leave that. I won't go into it. You remember the 3 angles in a triangle add up to 180? We don't need to write that down, do I? 3 angles in a triangle add up to 180. I've already talked about isosceles, equilateral, scalene. Special, don't mind that. Okay, right, that's fine. That's all we need to know for the moment. Right, today I'm going to talk about a shape that you wouldn't have come across in junior cert, and it's called a trapezium. Right, so a trapezium, girls, is a quadrilateral. So a quadrilateral is a 4-sided shape which has one pair of opposites, or which has one pair of parallels. One pair of parallel sides. Right, so a quadrilateral is a 4-sided shape, right? Okay, one pair of parallel sides. So look, this is a trapezium. This line and this line are parallel. Is that okay? Right, okay, a trapezium, it could look something like this. That is also a trapezium. It's one pair of parallel sides. Is that okay? So there's only one pair parallel, because if the 2 pairs were parallel, it would be a parallelogram. Okay, right, so one pair of parallel sides. Are we okay with a trapezium? Right, and there's a formula in the log tables for the area of a trapezium. Right, okay. Can I go up like this? Have I? Right, okay. So the area of a trapezium, girls, it's in the log tables. It's a plus b over 2 multiplied by the height. Okay, what the hell do I mean by a plus b? So here's my trapezium. Right, okay. A is the length of one of the parallel lines, b is the length of the second parallel line, and h is the height between them. Okay, so A is the length of one of the parallel lines, B is the length of the other parallel line, and H is the distance between it, the perpendicular distance between them. So if it was a trapezium that was like so, A would be the length of one of the parallel lines, B would be the length of the other parallel line, and H is the distance, the perpendicular distance between the two lines. Is that okay? Right, so, and you just fill out the formula, there isn't a lot to it. Right, okay? Right, I need to talk a bit about polygons. Right, I know I'm throwing loads of information at you, right, okay, but we'll sort it out when we do a few examples, right, okay, when you do a few examples. Right, polygons, right, a poly means many, right, so it's a many-sided shape. So if I had three-sided, what's it called? Three-sided, what's that called? A triangle. Right, if I had a four-sided shape, what's it called? A quadrilateral. Okay, I've drawn a square kind of, but it can be a rectangle, it can be a parallelogram, it can be four weird-sided, weird-length shape, right, it just has to have four sides. Right, what about a five-sided shape, girls? 5 equal sides. Pentagon. Pent is for 5. This will help you with your quizzing as well. Pentagon, so penta means 5, pent means 5, okay? 6-sided, hexagon. Now can I draw a hexagon is the question, right? So 6-sided is a hexagon. 7-sided, right, I am not going to even attempt to draw a 7-sided shape. But 7-sided, girls, is called a heptagon. 8-sided, an octagon, and that'll do it. Right, okay. If they go any higher, they'll explain what it means. Okay, is that right? So triangle, 3-sided, tri for 3, quad for 4, pent for 5, hex for 6, hept for 7, and oct for 8. Are we good with that? Right. When you get these sided shapes like this, you need to be able to work out what the angles are. So if you have the center and you join the center to each corner, now that's a very bad choice of a center, but you get the idea. Right, here's a center here. Right, if you join it to each of the corners, right, in the pentagon, girls, I have made 5 isosceles triangles. Is that okay? 5 isosceles triangles, as in these have the same length. Okay, is that right? Because I picked the center of the pentagon. Okay, so do you all see that this is an isosceles triangle? 5 isosceles triangles. You can work out the angles, because in the middle of the pentagon, there's a full circle. A full circle adds to what? 360. So if I divide 360 by 5, 360 divided by 5 is 80. No, it's not. It's 72. 72. Is that okay? Right, okay. So I can work out one angle. Then, because this is an isosceles triangle, I can say 180 take away 72 is 108, and then divide each one by 2. So these two add to 108, but they have to be equal. So this is 54 and this is 54, yeah? Would you agree? I know you can't see that right now, right, but that says 54. 72 in the middle, 54, 54. Do you all see how I'm working these numbers out? So 360 divided by 5 gives me 72. 72 from 180 gives me 108. And 108 divided by 2 gives me 54, because it's an isosceles triangle. You with me? So then over here, this is the exact same, 54 and 54. Would you agree? So then in the pentagon, each angle in the pentagon is 54 and 54, isn't it? So that would be 108. Would you agree? This one here is 2 angles from the isosceles triangle. That would be 108. This would be 108. That one would be 108, and the last one would be 108. Now you don't need to remember these numbers, right? Because not in a million years do I remember these numbers, but you need to remember how to figure them out, okay? So you don't need to remember what the numbers are. For example, here in the hexagon, what would you do? How many angles are at the centre? How many angles are at the centre? 6. So 360 divided by 6 would be 60, wouldn't it? So each angle there at the centre is 60. Agreed? Right. If you just take one of those triangles, it's an isosceles triangle, right? Okay, so this is 60. So that means these two here actually add to what? They add to 120, don't they? So that means they're 60 and 60. That means the triangle in a hexagon is actually a what? It's actually equilateral, okay? But I don't remember that. I just worked that out. Do you know what I mean? You don't remember these facts because you've enough to be remembered, but you know how to work them out, right? Okay? Right, that's polygons. There'll be questions on it, right? Okay. So what I'm going to do, right, because I'm not going to have time for an example, right, I'm going to give you page 166, right. So using all the facts that I've just told you about, right, okay, you should be able to work out what they're asking you. But as I say, girls, the questions, they're really hard on area and volume. They're really hard. So if you do page 166, if you do 1 to 6, and I'll correct him then on Monday and we'll see how he got on and talk about them. Right? Okay? And I'm probably going to do every single question because they're really hard. Right? Okay? Is that alright? So will you just have a go at those? Right? See, as I say, there's no new teaching to be done except the trapezium. Right? There's no new teaching to be done, but the questions are seriously hard. Yes? Post a picture, I will, of course. Yeah, thanks. Yeah.